Hello, everyone, and welcome to another episode of Observable Flutter. My name is Craig Labenz, and I'm your host. And today, we've got a pretty topical conversation. If you're still on Twitter, following other Flutter folks, you've probably seen a pretty darn cool demo of, well, we'll see. I called it an Ori and the Blind Forest clone. And my guest today and its creator calls it DoodleDash with lasers. But I'm excited to get into that. It's gonna be all about Flame and primarily, I think, shaders today. But before we get too far into that, just want to remind everybody, this is the Flutter community, so we've got a great reputation. Let's live up to it. Every week, the folks who show up here impress me, not only for your ability to put up with me, but your ability to never really seem to offend the code of conduct, which is great. But today I'm joined by Renan. Oh man, I had it. I'm joined by Renan. You have to remind me how to say your last name. I was practicing a few minutes ago, and then I lost it. Renan, I'm very excited to have you. I see you face palming backstage. Why don't you face palm in front of everyone and say a few words about yourself?
You almost had. Yeah, my name is Renan Araujo. Okay.
Araujo. Araujo.
Yeah,
Araujo.
Araujo. Yes, that's good enough. And I'm an open source engineer for the Unicorn Company, Very Good Ventures. So basically, my job is to maintain open source packages for the community. And I'm also an open source maintainer, all about open source, even if it's not my job. Basically through Bluefire, which is a kind of a collective of crazy people that maintain some Dart packages, especially the Flame engine, which is the biggest one, I think the most popular one. And also all the ecosystem around Flame, the bridge packages, Forge 2D, everything around that. And yeah, it's a pleasure to be here today, talk about these experiments.
Yeah, a pleasure to have you. So, you recently gave a talk. Was this at Flutter LATAM?
Yeah,
Flutter Latin
FlutterConf
America?
Latam. Yes.
Yeah, okay. And can you summarize and maybe show us? I don't know if you want to show it right away or summarize it up front or show that primitive version first, but introduce everyone to the project.
Okay, so this goes back a little bit. So back in Berlin, I had a talk about shaders beyond the gimmick, which is basically to showcase some possible ways of combining Flutter and fragment shaders. It's not fragment shaders by itself and not Flutter by itself, but both combined for real use cases for real world apps, day-to-day apps. But that question hangs around always when you talk about fragment shaders on Flutter. It is about how about games and how this combine with games. So for this talk in Colombia, it's kind of a continuation of that one. So basically, we explore that facet of the combination of Flutter, fragment shaders, and now Flame. So 3Fs, and you can combine these 3Fs and see the results. So for this, I wanted to just go the same way as did in Berlin, just some examples, nuclear examples on how we want to combine this shade or this effect for games or that effect, and I'll not connect to each other. But the last minute, I had finished my slides already. I did no, this is lame. I mean, let's do a game about this. So my talk was Tuesday. It was like Friday. I decided to start a game to showcase all these effects and combine them and see how those things combine. And the result was pretty fun. It was pretty fun to code too. But that weekend I had no life.
Yeah. Yeah, I would think not. So your talk was on a Tuesday, and on Friday,
Yes.
4 days before,
Yeah.
3, depending on how you're counting, you dramatically pivoted.
Pivot, yeah. So yeah, you're not counting that the talk, I gave the talk in Colombia and I live in Portugal. So there
Right.
was
So you
a
also had
day
to
of travel
travel
there. Yes. But I also coded, needless to say, I coded in the
on the
plane.
plane. Yeah.
Yes, if you see
Yeah.
my commit messages, one of them is like I committed this from the top of the Atlantic Ocean. Yeah, it was pretty fun.
Nice. All right. So do you want to maybe show folks the game who haven't seen these tweets about it that are going pretty viral?
Yes. So the game is pretty much this, right? This is the slides, by the way. It's not the game running on my computer now. It's just the slides showcasing how the layers work. So this game is like an onion. It's all about layers. So in this case here, this is just layers on a stack. So there are 3 different widgets on a stack. It's like a sandwich, and in the middle is flame. It's a flame game widget, and the breads are pretty special. I can talk a little bit more about those, but there are also shaders, but they are not inside Flame. In which I can create the vignette on the front, and on the background, a dynamic background that changes as you progress in the game. So if you play the game, you get to 1,000 points or something like that. The color will have changed already to a different color. So to a different scenery, basically. So the game looks more greenish than blue, you know.
Gotcha.
And if you see here, let me see if I can advance a little bit. So in between playing and then when the user dies, you see that the background changes to a darker version, lighter version in the background, darker version to a game over screen. So this is how when the game starts, seems like there's this effect of everything clearing up a little bit because we interpolate in between these 2 states of the background.
Mm-hmm.
But this is also a shader from the previous talk in Berlin, which is a mesh gradient. But we can talk a little bit more later.
Okay.
And
yeah.
yeah,
That back one, the effect you've kind of created, what I'm kind of getting almost is the scene is at the bottom of like a very deep well, and you're like ascending up it kind of with the whole rest of the game,
yes,
right? Obviously the whole game is about climbing, and then
yes,
are you basically just resetting the Y position when the character dies?
yes. So this is the fun here. We are taking advantage of everything that Flame gives us, and the latest versions of Flame introduce this new uh, community implemented, by the way, API, which is the camera component. So basically, it
Oh,
customizes how you see the world.
I
So
knew that was from the community.
yes, and I mean, in this case, without camera components, you are climbing. To create the feature of climbing, we would have to move all of the components, all of
Mm-hmm, mm-hmm,
the walls, the water, the ball, everything will be moving vertically for us to give this sensation of movement. In this case,
mm-hmm,
we just need to move the camera.
mm-hmm.
And in the Flame coordinate system, all the components, the platform and the wall and the background
They're all
rocks,
stationary.
they are stationary. Actually, to
Yeah.
create the parallax, the rocks and the
Mm.
sides have to move in the opposite direction the camera is moving, but it's way easier than just moving everything
Right.
that you have in the world.
Right. Yeah, that's a great visualization of those layers. That reminds me, the last year at I/O we had a shader based resource as well, the like sci-fi type game,
Yeah.
and a bunch of the talk about that was about all the layers that kind of came together, and it was also a stack, everything just positioned
Yes.
in place delicately with a stack. Okay, so what's next in our tour here?
Yes. Inside of this game layer, we have layers inside of Flame. So this is where the actual shaders inside of Flame are working. Let me just pause here, or maybe move to the next slide. So what we do here is to have several cameras and just put one on top of the other. So a camera is just a way to see the Flame world. So what we can do is to add a shader to that and say, this camera is gonna see the ball, and this other camera here is gonna see the platforms. And when you render those things and you pass the result of that rendering to the fragment shader, and the result of the fragment shader will be the result of the camera, you can have composition like this. And even more important than that, you can render the UI once, and the result from that you pass to your fragment shader. So this is why the reflective rocks and the water, how it works. So basically, it renders all these 4 layers here first, and the result of that is one rasterized picture recorder
image.
UI image, and you pass to the fragment shader, and then it can see the result of this, the composition of this 4, and create reflection of the water with the platforms here, if you see.
Nice. And are you using the animated sampler for that?
No, because this is inside of Flame, so that it's not widgets. So the animated sampler from the Flutter shaders package,
right.
It's made for the widget tree. So this means to render an entire Flutter UI, it has to go through all phases, including composite. And in the composite phase, it creates the UI image object. In this case, Flame runs entirely in the paint phase. So in the paint phase, we create a picture recorder, and we create a fake canvas. So these layers can know, for example, I have a ball component, and I say in the render method, I can say, if this canvas is my fake canvas, I render the ball. If it's not, I don't render anything, for example. And we create this fake canvas thing. I can show the code. It's pretty fun. It's pretty hacky.
I think I speak for everyone when I say we'd love to see it. Also, it's interesting that I remember reading in the new camera documentation on Flame that you can have multiple of them, but it never occurred to me that you could just stack them in this kind of way.
Yes.
I had assumed that cameras were kind of more like complete, and if you had more than one of them, maybe it was for like a mini map, or
it's great for that,
making Portal or something like that. But this is, like you said, just a lot more camera composition than had ever occurred to me.
Yes, it's rather than a line. This slide gives a streamline that gives it the illusion that everything's a line, but it's more like a tree, because these cameras here, these shaders here, should have rendered the other cameras first. They kind of have to contain the other cameras. So we have a camera that contains other cameras. It's like a tree,
Gotcha. Okay.
Yeah.
And because obviously Flame, has a component tree that is at least somewhat familiar to folks who are comfortable with widget trees. So do you have just one Flame world, and you're attaching different cameras to it? So it's still just one world.
One word.
How are you selectively getting like the ball to be the only thing that is shown in its camera, and the platforms the only thing that's shown in that camera? How are you doing that?
I think this conversation is calling for some code. So let's see some code. Yes. So I just wanted to showcase first. This is the game before shaders, the branch here before shaders. And it looks like this. So the platforms are basically these. I don't know how to describe these platforms. What this looks like.
Pills is the
pills. Yes.
The name they often get.
Yes, pills. So yes, lots here, lots of pills, colorful. You can jump around, random colors and stuff like that. So this is basically the game with the same dynamic, the same mechanic, without all the shader shenanigan. So how this works, the game state that we have here is basically this one is just over an enum. It's a qubit from the block, the Flutter block package. Initial, starting, player, and game over. Basically, that controls the game state. And you can use this inside of Flame. So on Flame, it's called Crystal Ball here, because this is development name of the game. The final name is Turi. Okay, its commercial name is Turi, but here you'll see Crystal Ball a lot because I thought this was going to look like a crystal ball. So I just chose this name. So yeah, this is
It
like
ended up looking like a turry.
yes, Windows Loghorn, for example, to Windows Vista, for example. So this is the kind of development name of the game. So we have the game here, Flame game, and finally the game widget, passing it basically. So
Okay.
here we inject the game qubit and we pass as a provider to the word, to the crystal word. Crystal again, it's going to appear a lot here. And we have here on the super method, we can pass the camera. So this one is with fixed resolution. So this allows that the camera will always have this size and consequently this aspect ratio, independently of the aspect ratio of the screen, of the window. So this simplifies a lot for us here, but in the real world,
what does it mean for the camera to have a fixed aspect ratio within a window that, cause it seems like it's still taking up all the space, or is it not?
Let me make it a little bit
Are
more
there
visible.
bars of colors at the top and bottom?
Let me see if I can run this. Okay, so let me just run. So everything the game is occupying, the actual view of the game is in the green area here.
Okay.
So if you resize,
Okay.
you'll see black bars.
Nice.
So it keeps the aspect ratio also the size. Because basically, how can I put this? It allows us, for the platforms to have the same size. So I have like 200 pixels wide, for example. You would have to change as the game resizes.
Oh, so it will scale things down as well.
Yes. So the game word is always here. Camera size, just a constant, 900 to 1600.
That's quite good. I didn't know that if you use the fixed camera resolution, it would scale things down. If the available space was like half of what you pass it, it will cut in half the size of everything.
Yeah, it makes the results more predictable, independent of the size of the application. But in a real world game, if you're shipping this to production, you want to be a little bit more adaptive to the aspect ratio of the devices. But this is kind of a gimmick, so I guess we're off the hook here. Okay, let me just put this back because this screen is hurting my eyes a little bit. Okay, and we have the crystal word here in which we actually add things. So we have a platform spawner, which is like a component that handles nothing. It just takes care of spawning platforms as the camera moves. So we spawn initial platforms when we press space and the initial platforms appear in the kind of animation way, in a sequence. This kind of gives a little bit of a cinematic effect. Let me die here on the game, of course, not for real.
Thanks for clarifying.
All right. And when I press space, you see this cinematic effect of the platforms appearing. The first one was green. That's why you're not seeing it in this background.
Nice. Well, how'd you find it? You jumped right off it.
I didn't find it. It was like
okay.
So yeah, this is the initial platforms, and it creates this sets this little flag to true, and on update, if this flag is true, and also if the distance to the latest distance to the latest platform to the top of the camera is smaller than this constant, it's spawn preloads more platforms, and we have infinite platforms. Another interesting component that we have here is the Reaper. That's also invisible, but it's in the bottom of the screen. So if a platform is under this Reaper in any given moment, this platform disappears. So basically, we don't have platforms after some below the screen after some tolerance.
Well, and also, that's a well-named thing destroyer.
Yes, because it's also a little bit green because it follows the camera, but only goes up. If the camera goes down, it means that the ball is going down, and the ball will hit the Reaper. And if you have a collision of the ball and the Reaper, game over. So this is how we have game over. Pretty much. And then we have a keyboard, an input handler for keyboard and mouse and touch screen. And yeah, lots of other stuff. The little ball and also the ground. Pretty much.
Renan, your audio is cutting out for me a little bit here. Can you all hear Renan okay, or is it just on my end?
Hello, hello.
Now I hear you great.
Did you have a problem?
Chat says it was cutting out, but I think you're basically back now. I think we're good.
Oh, fantastic. So I was just showing, I don't know until when you could hear me, but it's basically the mechanic of the game. And then we can see it with shaders now.
Yeah, let's start turning them on. You sound great. I think we just had a quick hiccup.
Ooh, all right. Maybe the connection here, I don't know. Let me exit presentation mode. All right. I think the things will be a little bit better now. Let me see, rerun this. Okay, I think it's better if I just stop this and run again. Oh yeah, I have to. I just set it into main with the latest version.
Yeah, Flutter pub get.
Yeah.
FPG.
It's a good idea. Yeah, I have lots of aliases here. Okay. We have now the game, the same game, same mechanic, with all of these things I showed you, and some are state. For example, we have high score here, a score qubit, in which we preserve high score. So we also have a high score thing with a hydrated state. And I think I'm injecting this, but let's go back to the Flutter side of things. See here, we have a high score qubit, it's hydrated, so it's persisted. And all right, we have lots of more stuff, lots of assets to load, because besides the shaders that are treated as assets on Flutter, we also have lots of little sprites for the rocks, for example. And those are very important.
No, so those rocks, they're like behind the vignette a little bit. We can just kind of see them, right? Is that what you're talking about?
Yes, exactly. Okay. And also this one's in the bottom here. There's some in the background that are not that visible. I don't know if you can see on the mouse here. Let me see if I can make it bigger. And
we've got we have a question from somebody impressed in the chat. They're asking, how long did it take you to write this game? I know you kind of answered it earlier, but
yeah, it's not. If I say it started Friday and ended right before my talk, yes, this is true for the game. But I also already had the shaders prepared, and I also kind of had how things would look like in my mind in that Friday. So I didn't go through research on game mechanics, because here again I just ported DoodleDash with a little bit of changes in the mechanic, and also didn't go through things like soundtrack, which is pretty important for a production game. So I didn't even look through that. So it's unfair to say, just 4 days, 3 days, you can make a Flame game 100% and look like this. No, it's like for reals in production, will take a little bit longer, and also to learn GLSL and stuff like that.
Yeah, and you mentioned you had been studying GLSL, which is the shader language, which we'll get into shortly. You'd been studying that for a few weeks before you actually started this project. And you gave a talk on it in the summer.
Yeah, no, GLSL.
Months you've been studying it.
No, I think it's a year now, and it's always in my free time. So you see, it goes like that. Whenever I have a free time, I look into it. But the specific effects and stuff like that, I have been trying and tweaking and looking to Shader Toy, for example, for a month now. So, I mean, I already had the talk with some of these effects already done by the beginning of before starting the game. That was
Mm-hmm.
how the presentation would go. But I decided to pivot and just compile these things, these effects that I already had, into just one thing, for example.
Gotcha. Yeah. Yeah. Nice.
Yeah.
All right.
right,
So we're loading the assets and these rocks, right? That's what we're talking about.
Yeah, the rocks and also the shaders. So we are compiling the shaders too. So load assets. I have assets cache. With assets cache is my special objects I created. It's basically images and shaders. When I have a soundtrack, it will go the soundtrack here too. And loads all for image is basically, loads into
Nice,
the flame.bundle. And then we have the bytes saved in memory, pre-cached for us. And also the shaders, which is basically creating a fragment program from the asset name that I'm using, for example, here, shaders platforms, shaders the ball. And they're all saved in the structure of the game. Here, under shaders and the ball, and then referencing then on the pubspec YAML. Here, under Flutter shaders. Yes, and also I'm using Google Fonts for the fonts on the high score, for example. But that's, I think it's preloaded when you get to this screen, right? When it starts the app, it's preloaded.
So to summarize so far, you to connect shaders into, and it's funny, this is content that you and I have each put out guides on, but to summarize it again here, to get shaders into any Flutter app, this is not unique to Flame. You both put the raw GLSL files in your assets directory and declare them in your pubspec file.
Yes.
And then you have to have some specific Dart code that brings each one in specifically, and that's where you were doing that in the asset cache class.
Exactly this. So this basically compiles to a program from that GLSL file, basically. Or you can make things really, really short. Self plug here. You can use a brick for that. So you can use for Mason.
Nice.
Make Flutter shader, name my shader, and you run this in your project's root repository. Also, you're gonna need this Flutter shader brick, and it will create a file for you and also add to pubspec. So you will need to hook in the Dart code to compile the thing, but there's also a little boilerplate here already created. So makes things.
That's a great brick.
It's a brick. Let's throw bricks. Let me just undo what I just did here. We're live coding and we don't want to mess with the code base, right? Okay, so yes, this is what we're doing, and at this point in time, we can load the game instance with the assets already preloaded. So we already have the fragment shaders instances, the images, and everything ready, just to put on the canvas or to apply to the canvas.
Yeah. So you got a lot of startup code here. In your experience, how is the startup performance of this game?
Oh, it's pretty fast.
Just like totally fine.
Yes. Yeah, you barely see the circular progress indicator that we have here. You barely see.
Yeah, someone was just asking, like, how big are the GLSL files and whatnot, and they're really not very big. So those must take like microseconds to load.
Yes.
Slowest thing would just be getting them off file system.
Absolutely. And it's goddamn fast, but we can talk about performance later, because here we have 6 shaders working, how this add up to performance. Right. And I have to tell you already now that the most expensive thing here is the dynamic background, because that's using draw vertices in a very not optimized way. So if you remove the dynamic background from the equation, it's under a millisecond in profile mode.
Nice.
All right.
Chat continues to be impressed, by the way, bro. That's insane.
What are you
And
building exactly?
he's building a shader-heavy port of DoodleDash, a game from about a year ago.
Or a clone of
Yeah,
Ori.
or a clone.
Yeah. Oh, we just saw a bug live here. Let me stop playing the game live.
I'm not gonna lie, I didn't notice.
Oh, awesome.
Oh, I
I
love how you bounce on the ground. That looks actually pretty cool.
yes, I can go in details about that later. So we have the game here, and we also now we have lots of more stuff in the equation here, just to make sure that things are the correct color around the vignette. We have a colored box that's black, and in the game widget, you can pass lots of Flutter widgets to interact with the game. So for the background, you can have an entire widget that's a background. In this case, it's the center with aspect ratio of 9:16, so it has the same effect of the camera. And then you can pass dynamic background. And then you can put overlays that's above the canvas in which you're painting your game. And it's under the hood, it's our stack. It's just a stack. And we have high score and score while playing the game, and high score when you're not playing on the game over screen.
Oh, quick,
And a
one
vignette.
real quick. This is
Mhm.
just the best tour of code I've ever had in my life. But good comment from the from
Ooh,
chat. Yeah, bigger font, perfect.
totally
Thank you,
forget
S
that.
man.
Sorry, chat. Forgiveness. So the dynamic background is a little bit heavy, but it comes from this little editor that I'm still to release as a Figma plugin. Basically, you can edit mesh gradients in this app, and then you can export a hash, and you can use mesh gradients in any Flutter app, and also animate them because there's a linear interpolation between different states of the mesh, and it's pretty flexible. And under the hood is using draw vertices. So this is how this mesh is basically being added, and it's also a shader that takes care of correctly interpolating colors in between the control points. But this is something else. It's not related to games. I just wanted to use this here, and then you can export this hash and use as a state in your Flame game and your Flutter app, any Flutter app. So there's this animated mesh gradient widget here that will pass the data. That's basically comes from these hashes here, just binary versions of all of the points of the dots and its colors.
Yeah, it looked like base 64 encoded or something, maybe.
No. It's just binarized. So I use a package called binarize to binarize the states, and then I use zip to minify it. Yeah, there's some things under the hood, but it's not base metaphor. It's way shorter than that.
Got it. Okay.
There's lots of states here. It's like 25 dots, each
see.
dot with a color and coordinates, yada yada. So yeah, so let's see. This is the initial. Let me put into the correct setup here for us. Let me go again. Just froze a little bit. Did I freeze for you?
No, yeah, at least not on my end.
Okay. OBS is taking a toll on my computer.
It does.
All right. So basically, we have this is the initial. When you see on the game over screen, on the initial screen with the logo, you see this background, and then when you start playing, this is the background. You see that you animated between them. Let me just.
Oh, and this is the mesh that you were just showing us. That's how this is changing.
Yes.
You're just pulling some of those control points down.
Exactly, and also change colors of some of them. See, and then if you reach like 1,000 points, for example, you reach this state here, it's a little bit more different, So
Whoa.
the vignette will take care of everything around being, darker, but the background color just changes to this kind of more greenish type of blue. So, and you can go like infinite. One effect I was planning on doing, but it's gonna take some efforts, is doing kind of storm in the background where you see you know, I don't know how to say in English. Sorry. When you have a storm and you have electric, lightning. Yes. So do some kind of effects of lightning while you're playing. Should give some more, cinematic effects and stuff like that. It's also possible.
That's just you flexing your shader muscles again. Just like, oh, yeah. I'm sorry.
But,
oh.
But this is the thing. This mesh gradient is not only shaders, it's shaders and draw vertices. So this is the fun thing about fragment shaders on Flutter. Flutter is how powerful, lots of APIs and lots of numbers that you can get from everything, from scroll, colors, whatever. And then you can pass those numbers to fragment shaders and decide what the outcome will be. This is the flexibility that we're talking about, and it's pretty fun.
So Ziedenstein asked, what app is that? And I'm tempted to answer, this is the upcoming new Flutter counter app.
Yes,
you type Flutter create. Yep.
Yeah.
You're going to start getting this. The counting is climbing, of course. It's the future of Flutter.
Yeah.
No, it's a game that Renan made and gave a talk about last week or 2 weeks ago, maybe. And now we're all getting a walkthrough here.
And it's also open source. So basically we can...
Oh, yeah. Let me share that Git link.
You can just see this code, this bad code. So put up with, like, bear with me, I created this in 4 days.
Oh, open in new tab. Thanks for copying that, computer.
You just had one job, man. Just kidding.
Too many jobs.
Too many.
I can't handle one job.
Tutti opens. No, it's just Tutti. Just Tutti.
So it says opens in new tab. All right. One day.
One day. I have a dream. Someday you're going to have my link on the screen. Yeah, thanks. Yes, this. Oh, I forgot to put a license, but it's going to be MIT. So whatever, do whatever wants with this code. Publish paid versions of this on the store. I don't care really. Just I care that people learn. And I think probably going to add this to the Flame repository as an example, the way it is. And then I can work on more features to go to the store. But yeah, that's it. So pretty much the same thing with extra stuff. Game widgets, not game widgets. I wanted to go for my Crystal Ball game. That's not Crystal Ball, it's Turing. So here things changes a lot. Okay, so here is where things start to get funny. So remember, we use just one camera and one word. In this case here, we're gonna have multiple cameras, one word, actually 2 words. One is a dummy word, that because for a camera to render something in the screen, you need to have a word. So I created this one. Okay. And we have a camera with cameras. All right. And this is not anymore just a camera component, is a custom camera class I created. It's called sampler camera. That's kind of the animated sampler. Works almost the same way.
Okay.
And then we have one camera that doesn't contain shaders, which is the bottom one, called the classic camera. Uses the camera component. And this one renders the logo and the background rocks. I don't know if you can see here. There's also a background pillar of rocks.
Yeah, very
that
subtle.
Goes always with you. Yeah, I should make that less subtle because it's pretty invisible now. It also creates a parallax effect and stuff. For this one, we don't apply any shade. We have a fog camera, which is a fog that's part of the level in which a ball is. So there's 2 fogs here, fog in the foreground and one in the background. The foreground is in the same level as the rocks, so it's not reflected in the water. But on top of the water, we have another one that's just on this camera. We have a platform glow camera. That's just the platforms, the ball camera, and pretty much it. And the camera with cameras is responsible for applying the shader of the reflection, applying the shader of the reflective rocks, and pretty much, and the foreground fog. So one camera is responsible for all of those things. And
Okay.
this is kind of how it works. Let's go for I think the easiest one is the ball. I created this kind of thing that's the sampler owner. It's basically the thing that controls the behavior of the shader.
Okay.
And basically here we can have, we can say how many times this camera will render the canvas before getting here. So if I have like 3 passes or 4 passes, the image resulting of these passes will come in this list here. Here is 0 because we are painting the ball. So this is the gotcha here. The ball itself, the component, doesn't paint anything. It just holds the state in which where the ball is, and we pass this state to the shader. So we pass the UV ball, which is the position of the ball within the screen, to the shader, and the shader will look something like this. Project shaders double. So now bear with me. So starting from the main, I like to create this little boilerplate here in
Yeah.
which I
So
calculate the UV and stuff.
I think we should have a bit of a intro to just what we're looking at here, right? So shader
Oh,
code is not written in Dart, and it's instead written in this other language called GLSL. Other platforms use other languages for the same thing, but Flutter uses GLSL, which stands for what? OpenGL shader language.
pretty
And
much.
the the purpose of this code is, first of all, it's run once for every pixel on the, well, in the space of that the shader is operating, which could be the whole screen or it could be part of the screen. This program is run once per pixel per frame, and its job is to, first of all, grab the pixel that it was passed, and that's what Renan is doing on line 56. The Flutter frag chord, that's the coordinate of the pixel that this instance of the shader program is running on for this frame. And so it gets that coordinate, and you can get the potentially there's an initial color if the shader is modifying some other UI, or the shader can be from scratch. So you maybe get the starter color from whatever was there before, and then the whole job of the shader is to maybe change the color of this pixel. That a pretty good summary?
Yes, pretty good. So I like to say that every fragment shader works like a function where inputs parameters are this that you get from the framework, which is the coordinates, and also the things you pass from Dart, which is called the uniforms. In this case, we have the size in which we are calculating, the rectangle that we are calculating at all, the light source, which is the position of the ball, the velocity of the ball that we use here for the little tail that grows as the ball goes faster,
Mm.
the brightness and radius of the ball that can change. So this is a thing that we could change, make the ball blink with game events, for example.
Mm.
And we use all of these numbers to create a number that's also, colors are also numbers here, to create a color in which we will tell the framework, well, this is the resulting pixel, including transparency.
Mm-hmm.
And this is the actual where things are going, how things are happening here. So, for example, here I give the ball size, light source, the distance from the actual pixel that I am. Let's imagine I'm on the pixel that's on my cursor here. So the closest this pixel is to the ball, so the closer the ball is to this pixel, the brighter it gets, right?
Mm.
So this is pretty much how this happens. We get the distance to the pixels to the current position of the ball, and from that we create a glow effect. Uh, and also there's this extra function here that's responsible to also add the tail. So it creates kind of a section of line that's based on the position of the ball and the velocity of the ball. So if the velocity of the ball the ball is moving vertically with some certain rate of pixels per second, we can create this tail and create an extra brightness there. And basically what you see here is the color of the tail. So let's change a little bit this for, I don't know, totally red. Let's see, do we have water load here? Oh, I hope we do.
Yeah, it works for shaders in general, but Flame doesn't have hot reload, right?
No.
So while you're doing this, I'm going to answer a couple questions. Someone just asked, is there a wrapper package for GLSL? And to that, I would say kind of. The Flutter shaders package helps you just set up the glue code to get it into your Flutter app. But the code that we're looking at right now is up to us as shader users to figure out.
Yeah.
All right. Yeah, the tail is red.
The only part you can have on Flutter using GLSL is this one. That gives us this thing here, if I'm not mistaken, right? Oh, Jonah Williams, you have to help us with that. I'm not sure, but this is the only one I use. I don't know if I have any U2 functions or anything like that. And yeah, so I just changed the color here to completely red, and you see that the tail is a little bit different, you know. So this is the fun about.
Can we make the tail bigger? Can we make the tail longer?
Oh,
do you remember which line of code even does that?
Oof, it's gonna be hard, but I think we can make change this, you know, not divided by 30. Let's go divided by 15. Run.
And by the way, Hanan, we'll have to go back to your mesh tool. I think that was in Figma, I thought you said.
Oh yeah, I'm working.
And...
Yes, I'm working for a Figma plugin in which you can just do this on Figma, and you'll have a design with a mesh gradient. Then we have this little hash here. You just need to pass this in your Flutter application, and it will run. You know, so the designer can have the job of designing the mesh gradient, and we just don't need to worry about anything. Just pass this. And,
so is this Figma plugin still in progress, or is it released?
Oh, no, in progress, pretty much in progress. And this code is not optimized, so I still have to do lots of stuff. But it's pretty, in my opinion, very useful for lots of things already. So you can control tessellation of the mesh, stuff like that. But
wow,
I still don't have like Command Z, for example, undo, redo. That's pretty important, you know. So yeah, I think we made a little bit longer and red.
Oh, you did? Yeah. What change did you make? I was looking at the chat.
Yeah, you were looking at the chat. So this color, R, G, and B.
Yep.
Basically. So this is the color of the...
sorry. I saw that. How'd you make it longer? What change did you make for that?
Oh, I just changed it for how much I'm dividing the ball velocity. So this is the thing. I'm multiplying the velocity x because the horizontal velocity is pretty meaningless compared to the horizontal at some points. So that's why I give a different treatment to the x than the y. You know, the x is the double.
Okay.
Yeah, that's pretty much it. Divided by 15.
Someone, MD Yassine says shaders are math, and yep, they sure are. Which is why I'm not good at them.
Yes.
Yeah, that's pretty cool. It's fun to see the tail when they hit a platform. The tail actually kind of flips under the platform.
Yeah. So this is kind of an illusion that it creates. You know, people are saying on the event that to me like, oh, I like the little bounce effect in which you squeeze the ball and it bounces. I don't squeeze the ball and it bounces.
Oh,
so it gives us this little
the tail makes
illusion.
it seem like it.
Yes.
Yeah, I had the same thought actually, that the ball was being kind of warped a little bit at different points, but it's all just the tail, I guess.
Yep. Yeah, pretty much it for the ball. So this is how we create this one. And also there's the platforms. So I have to do a disclaimer here. I'm not an expert on GLSL. I just like to combine different effects with Flutter. So some of them, I just followed some tutorials. So for the ball, see the code is pretty big and we have lots of customization, but this is just customization on top of a tutorial that some kind person did on Shader Toy. So this is a tutorial.
You started with this.
I started with this. It's good to understand. This is amazing. I think you can pass the link here if it fits better, if you find it fits. So this kind of explains how to create this kind of glow effect. And then we can control intensity, glow, radius, yada yada yada. They teach you where you want to tweak, where you have to tweak to change things. And then we can just connect the wires. So we already have a calculation here that's default to the center of the screen. The UV 0505, 0.5, 0.5. So we can just wire that to the position of the ball, for example, tweak some stuff, and then just tweak also an extra function of this to possibly create a trace, which is this one here, a little tail, and experiments with functions. GLSL has lots of funny functions that can help you to use math for tons of stuff.
So you mentioned the camera sampler that is similar to the animated sampler.
Yes.
And
ooh, that's funny code.
Could it make sense to look at that?
Yes, makes sense. It's brace yourselves. It's not. It's funny code, but it's not the most beginner friendly.
Yeah, I know. In the animated sampler itself, it's some of the least approachable code you'll ever see in your life. Because
this
it
is
just
worse.
was like, oh boy. Did you talk to anybody? Did you talk to anyone on the engine team, or did you just bang your head against the wall until you figured it out?
No, I mean based on the animated sampler. So the animated sampler is complicated, but once you grasp what's it doing, it's pretty clear. The composite phase, when you understand the composite phase, what's it doing, when that's being run, it's pretty easy to understand. And here, to apply to this concept, you just need to remove the composite phase from the equation and work with a picture recorder and canvas.
Got it. Okay, right. Because Flame is all just one painting operation, as opposed to all the abstractions of the widget tree to the render object tree to the layer tree.
Yes, exactly.
Yeah, you skip all that.
It's just I like to say that Flame is a custom painter with lots of extra vitamin. So if you have collision detection and physics and all of this kind of stuff, but in the end works just like a custom painter. So okay, let's look from the ball. I think the ball is the most simple example we can go, or maybe the platforms, but let's go for the ball. Let me just make more room for the code here. Oopsie doopsie. All right, so we have a sampler camera, okay, that afterwards we are adding to the camera with cameras. This is the thing that's going to the screen, but it's actually the HUD of these components. And the word for this camera on top, just a dummy word, doesn't paint anything, but it will use the HUD to pass through its own shaders. Back to the ball camera. This is a sampler camera. So in this case, just extends camera components, and then we create some of the default behaviors, especially with the fixed resolution. This is just copy of the camera fixed resolution because it's a factory.
With the parameters,
yeah. So it's just passing through stuff. Okay, but this is the important thing. So here we create a layer, which is this custom class that I created too. It's a fragment shader layer. And what this does, on its render, you read the passes. Remember the passes?
There was a parameter on what was that on?
It was
on a camera?
On the owner. So basically you have a sampler owner that's tied to the camera, and the layer is also tied to the camera.
And you're just passing it through there on line 25. Okay.
Exactly. So we are doing these passes. Oh, that has to be final, by the way. You cannot change in runtime the amount of passes. It won't have an effect. Okay, so we have passes here, and then for each pass, we run this method. Basically, create a picture recorder. This is from Flutter. Creates a recorder here. Then this will create a canvas. This function here, just gonna go to this habit row next. pre-render. So basically, you're gonna render on that canvas. From that, create a picture, and from the picture, use TrueImage sync to create the image that we're gonna save on the list, and then pass on sampler.
Yeah, so part of a couple of these layers here, I want to add a little more color to. The can you scroll up just a few lines here? Yeah, so in this method, one thing that isn't obvious unless you've either read a bunch of the code or talked to someone about it is like canvases, and you draw to a canvas in a custom paint widget in its inner painter object, and so you have that canvas object passed to the paint method, and you'll do canvas.drawRect or whatever, and that canvas is actually just a recording of drawing operations. And it doesn't actually immediately render anything. It just is like, okay, you want me to draw a rectangle later? I'll do it, I promise. And so this recording is basically just piling up a bunch of drawing instructions that are happening in the pre-render method, I'm guessing.
Yes.
You're calling on line 34. And then to image sync, this actually kind of flushes that little mini inner, it's like a little pocket universe of rendering of this canvas that he created. And then, okay, now we'll actually apply all those drawing operations that have been stored up and spit them out. And finally, we get something that is an image, every day people would recognize, like, yeah, these are pixels stored in an XY arrangement.
Yes. Oh yeah, and pay attention to this. Picture ratio matters here. The size in which you will create the image has to respect picture ratio. And this is coming from the game. Oops. Command Z, very important.
Yeah, and earlier we were talking about how shaders can either start from scratch or they can modify pre-existing content. And this is that pre-existing content. So the output of this is what's going to go into the shader.
Yes, so there's only one of the cameras that actually uses these passes. So you see platforms, the fog in the background, all of those, they have 0 pass, but the reflection ones need. So this is how the reflection will know here, for example, as the result of the other layers, where my mouse is right now.
So I still haven't fully actually internalized what this passes mechanic does. So is it like it's going to call the thing multiple times? If you have passes of 4, it's going to do something 4 times.
Yes, it's going to make sense now. Okay, so I said earlier that some components can choose to render one thing to one shader and another thing to another shader. For example, here, for the background rocks, we have several, for the reflection, we have several passes. So on the reflective rocks here, we are reflecting only the platforms and the ball. We are not reflecting the background. So for this pass, it's not interesting to paint those rocks. So this is how the component can choose. The secret here is on the canvas creator function. And in this case here, we don't create a canvas, we create a sampler canvas. So this is the fun part. We're prepared. Oh, I love this part. So this is a class that implements a canvas, and it receives an actual canvas. And all of these methods, draw atlas, draw rectangle, everything just forwards to the actual canvas. But this thing here contains 2 informations: the owner, who is the owner of this sampler canvas, and also which pass is happening. And if I go for the rocks.dart, on the render tree, I can say if this canvas is a sampler canvas of the ground sampler owner, which is the owner responsible for the reflection and the side rocks, and if it's on the second pass, I render. Otherwise, nothing gonna happen. It's not gonna paint anything. So this is how it's working, you know. This component, bottom rock one, is just choosing. It's a component that contains a sprite component. Chooses to render only for that owner on that pass.
I see. So I
Yeah.
had initially misunderstood the pass parameter as like,
Oh.
almost like if you're rehashing a password or something, like we're going to do
Ah.
it past number of times,
Ah.
but that's not what it is.
It's passages. I don't know.
Yeah, it's almost like a phase, right? You've got different
Yes.
phases of the rendering, and each of these things can opt into a certain phase, and then they do nothing on the other phases.
Yes.
But
So this
pass
is
is also a good word.
the most complex sampler owner that I have here. So we have first for the reflection of the water. So we have a shader and we pass everything. But see that this one has two passes. Pass that will be reflecting the indexes 0 and 1, right? And then we have two images here in this list. For the
No,
first
actually,
one,
I still had it a little wrong.
so if you say two passes here, then in that
Uh-huh.
for we will render once and render twice,
Okay.
creating two sampler canvas. The sampler canvas of the first time will have the pass field set to 0, and in the second one is set to 1. And this is the way in which the render tree will be able to decide if I render one thing to the shader, another thing to the other shader, or not render at all if it's not the certain conditions that I want. So for the fog, we have a different routine, and there is also the reflective rocks here. That's also a different routine. In this case, the rock shader uses two UVs, the two different images from the two different passes. Yeah,
Interesting.
it's pretty fun.
And we're in a sampler owner right now.
Yes, it's the ground sampler owner. I have to rename
Okay.
this because it's not on the ground, but also the reflective rocks.
Yeah.
So one
Okay.
owner doesn't need to have just one shader. In this case, we're using the rocks shader, which is the reflective rocks, the fog, that's the foreground fog shader,
Okay.
and the shader by itself, it's the reflective water. And okay, so this is how the reflective water works. We have the image from the pass 0, which is the result of the other cameras, right? And I pass to the shader as an image sampler. And I also pass the size, the UV ground, which is the position of the ground in relation to the camera, and time for animation. Time is pretty fun because it's just a double that increments on update in the game loop. So whenever we tick, we update this thing and we update time, and we can animate the little waves in the game on the water. And okay, fragment. Let me find the shaders for this. This is the water reflection. This is pretty simple. What we do here is we have the water level. Sorry?
Yeah, pretty simple.
All right. So if we are above not above, below water level, which is in this case is where my mouse is, we're gonna do these things. Otherwise, I'm not gonna do anything, just render the original pixel. Okay. And in this case here, we are changing the UV of the current pixel. So here we're considering, for example, if I'm on this pixel, it will not go over water level. So I'm going to use the actual pixel from the handwritten canvas. So it's going to preserve everything that's above water level. But if you're under water level, you're going to change. You're going to modify stuff. And this is how it works. First, this line is just to reflect, to invert. So if you are on this pixel here, you're going to get the equivalent pixel on the top of the water.
Okay, makes
And
sense.
there it goes. So this is where the reflection happens. Then we magnify this thing. This is kind of custom code here. That in this case, I'm kind of squishing the image, the reflected image from the top of the water, just squishing. So this is why we are reflecting the platform here, but the platform is far away from the water. You know, in this case we can reflect more stuff because the water level is really close to the bottom of the screen.
Yep. Yeah, that makes sense.
And then we use lots of this. I'm gonna be sincere with you. I don't even know what's happening here anymore. So I have seen, and it's based on time. It's based on the original
some
UV,
other stuff, and
yada. I tweaked this a lot, and then we can distort the image both horizontally and also vertically. And this, again, it's an adaptation of a shader on shader clay. This one. So see, this is the line in which I don't know what's happening. Anything's happening. Which is pretty fun. Nice. And the effect is here already.
Yep. Yeah, I love talking, or just kind of seeing here how much you obviously have some really impressive stuff with the camera sampler and this idea of the different owners and the passes and whatnot. Like, some pretty cool architecture that you've done to bring all this together. I don't want to minimize that at all, but also a lot of these individual shaders, it can be a matter of like copy it out of Shader Toy, change some of the glue code so that it can get the parameters from Flutter.
Yes.
And then even if you don't really know what's going on, just start changing values, see what changes. And over time, you'll figure out a little bit of what's going on and just keep going.
Yeah, see, here just change the color of the water. So the water is a little bit more pinkish, for example. So I can change the reflection. All right, let me run again. This case is reddish, That's quite pretty much. Yes, it's blood.
Perfectly red.
Perfect for Halloween. Yeah, let's go back to normal. So yeah, this is how the reflection of the water happens. So I have this special function here that uses the game canvas. It's also the thing that we pass there from the image 0. We sample with the distorted UV. That's pretty much it.
Dang. Over time, over the last hour and 8 minutes, a couple of people have inquired into the performance of this.
Oh.
And inquiring minds want to know how many frames per second can this do?
I have a video. I think it's easier if I go with the video. It's actually a little slide. Let's go for. I should have this prepared. Let's go. I knew that people would ask about that. Let's go a little bit further.
Is this a thing that Flame offers a helper for? Does Flame have like an FPS component?
Yes, Flame has an FPS counter, but the best thing to measure performance in the end for the end user is the same as Flutter. So this is the fun about Flame. Flame is Flutter. So we can use the profile overhead here. So this we are seeing the game running on my M1 MacBook Pro on a 100 Hertz display in 4K. So it's pretty demanding. And you see some spikes. So for now, it's under 1 millisecond per frame.
Yeah, that's incredible.
Pretty fast. But you see when the game starts,
I did see some spikes up to like 8,
spikes
9
here now.
Was the highest I saw.
Yeah, see this?
But to be clear, so this is
the dynamic background
4,
interchanging.
6 milliseconds, back down to 4, 5, 6. So it's 16 milliseconds per frame to have 60 frames per second. That means 8 milliseconds per frame for 120 frames per second.
Yes.
And the UI thread in the raster thread, the raster threads on top, UI threads on bottom, they they simultaneously are concurrent and not concurrent. So on a given frame, first the UI thread has to go, and then the raster thread kicks off after the UI thread finishes. So the UI thread is like your Dart code, the raster thread is the shaders and stuff in the engine, and they cannot overlap. But while the engine is computing one frame, if needed, the UI thread can be working on the next frame. So like frame 1 can be getting finished up in the engine while frame 2 is getting started in your UI. So they can kind of overlap, but for a given frame, they cannot add up to more than, whatever your budget is. But I'm not seeing it reach the budget here. And you're
No.
in, full debug mode.
No, this is profiling and
Profile
release
mode.
mode. Yes.
In
You see
release.
these spikes here. This is dynamic background, and when the dynamic background is doing a linear interpolation between meshes, we have this kind of spike.
The spike, I see.
Yeah.
And that's that big mesh that you were showing us, right?
Yes. So it's not even inside Flame. It's something that we can optimize a lot more, because I'm iterating. I'm just doing dumb code there, iterating on the vertices, every frame, every interpolation frame. So we can optimize that a lot. But if we remove the dynamic background from the equation, just the 6 shaders, the actual shaders in Flame, the result is this, what you see on the screen now.
Yeah, there's nothing about those shaders. Obviously I didn't study the shaders that you've written here, but nothing that I saw suggests that they would be any more complicated than any of the other shaders. Everything any Flutter app has ever rendered ran through a shader, even the counter app. That's the only way anything is rendered. And yeah, it's like that math was kind of hard to wrap your head around and fully realize, like, why is it sine times 0.8, all this randomness, but like that doesn't make it harder for the GPU. So those shaders are like hard to reason about, but they're not hard to execute. So this would be, should be just blazing fast, and we can see that it is.
Yes, and just compose. I like in your video when you said basically when you're doing fragment shaders, just saying Flutter engine, don't worry about the color of this pixel. Let my fragment shaders figure that out. So this removes lots of work from the framework, and then you can just do a little bit more straight up job to decide what's going to be on the screen. I really like that.
Yeah, what Flutter is essentially is a translation layer between the widgets that we write and the shaders that actually realize that UI dream. And so if you ever supply your own shader, you're just short circuiting all that work, and you just get right to the final thing that runs on the GPU. It's super duper 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 fast. And you get your frame in shockingly short amount of time.
Yes. And yeah, so this is pretty much it.
Incredible. And a really, really good tour of the code. You were extremely organized and had a nice logical progression through all of this. That was incredible. All right. I've saved some questions here. Some are related to what we're talking about. Some were not related. I've already gotten to a handful of them here. Let me go back. One person asked, what platform are you using? Merv Software. John, you want to do the honors and answer that?
I mean, the editor, you mean?
I think they're wondering, maybe they mean the IDE. That's interesting. Someone else did ask what IDE you're using.
I'm using Android Studio. Yes, I'm using Flutter as the platform to deploy. This is a macOS app running the debug mode of Flutter, and this is just Android Studio with presentation mode and high contrast theme. I love high contrast. Use high contrast. It's good for the vision. No, it isn't, but it's good.
But it's good for you if you like high contrast mode.
Yes.
All right. I starred some other questions. Let's see here. A lot more folks very excited for both you and the quality of this app. Arafat, very proud of you, as we all should be and are. There, so a couple questions, and on, we're just, these two are getting into generic Flutter stuff, but I'd be curious about your thoughts about this as well.
State management. Oh my god.
No, actually, I don't think we had a single. This might be a record. I don't know if we've ever gone a stream without a single state management question. We'll probably get one now, but it won't count because it's just because we're talking about it. We didn't get an earnest one. But no, some folks, this one's specifically about a book to get started in Flutter, and then separately just like advice for diving in. And obviously the Flutter DevRel team, we think about this all the time. But Renan, I'd love to hear your thoughts on leveling up in Flutter.
It's been really fun, all this journey around Flutter for some years, that we kind of forget how to start again. If you're going to start today, I'd probably start from the official documentation. This is just me. Maybe I'm not the best person for book recommendations because I don't read much books to learn frameworks and technologies, just overall patterns, stuff like that. I totally recommend the game development patterns from Bob.
Bob Nystrom.
Bob Nystrom, to really understand what's going on. It's beyond. I think this was a recommendation by Philip in Prague, and I can just second that recommendation because it's pretty good. It's pretty good. You can understand things like the game loop and several other concepts that we have here. For example, noise. We use noise here, for example, for the fog. So it's pretty interesting to learn some of these things through this book, but it's not specific to Flutter. For specific to Flutter, I think updated and trustable resource is, there's nothing like the official documentations. They're pretty good. This is how I learned Flutter, is through the official documentation. And
yeah, gosh, the Bob Nystrom, I didn't know this. I read most of his book a handful of years ago and I didn't actually finish it, but only because I didn't really keep going on game development. It's a really wonderful, delightful read, and had no idea, years later when I joined the Flutter team, Bob is one of the primary language designers for Dart. So read that book, a long time ago, and then went and started working with its author, which was a funny moment for me. I was like,
you make the connection.
Yeah, I was like, oh my gosh, you're that Bob Nystrom. And one, I haven't been much of a book person as well. I know for some people, certainly the person who asked, like, what's your book recommendation? Books probably their preferred style of learning. Someone in the chat answered the Flutter Apprentice. I think that's probably quite a good answer. I know that they're working on a refreshed version of the book as well. For my money, personally, I really like just long video tutorials. So I learned Flutter by going to Udemy and spending $20 or whatever it was and buying a huge tutorial. Just went through the whole thing, coded every single step with them, paid, fully turn my brain on, internalize everything they're saying, pause and think about it if I don't understand immediately. And because one thing that I found when you go through the official documentation, and as a Flutter team, we're trying to think about how to, cover this gap a little bit, but you go through the official documentation, you learn a lot of little components, and then you start to think, all right, I know how to make widgets. I know how to do these trees. I know a couple layout things. I have some idea about when and how to call set state, but I'm lacking this holistic picture of how to bring it all together. If I put my code here or there, is it a bad idea? Is it a good idea? How are people writing real apps? And the long video tutorials is what has worked for me. So one data point to consider.
Yes.
Oh, Majid's writing a book.
Yes, Flutter engineering. Totally forgot, but yes, it's he said it's gonna be a huge book. Totally gonna buy that. his talk in Colombia was about some of the contents, and it's pretty interesting. Some of architectures that we can use with Flutter that I never heard of. It's pretty fun.
Incredible. Wow. Yeah. I forget if I had heard that he was writing a book and forgot, or if I just hadn't heard. But well, Renan, I think we have done this code justice. I certainly understand it a lot better than before I had ever seen any of it. Well, that's good. And I think we've hit all the questions. And I think folks would be we're happy that you were on the show this morning. A lot of love, well earned. This is really a heck of a demo. I'm sure folks in Colombia were like, as just as slack-jawed as we've all been. And on any final thoughts?
I just have to say thank you to a lot of people, especially the people that in the past years have helped Inflame a lot, especially Lucas Klingsbo. Lots of APIs that I have to rely here was designed by the folks, by the community, and also by the folks at the Flame team. So I really am thankful to these fellows, and also all the job of the Flutter team on the fragment shaders that has been evolving a lot recently, especially on Impeller. So yeah, I just have to thank and also thanks a lot of the folks that make those shaders open source either via Shadetoy or GitHub or anything like that. That allows people like me to get introduced to this word without much hassle, just with the material that's available for free in the internet. And as a thank you to all of that, this code is totally open source. Clone it, publish it, whatever. It's just so people can learn.
Man, very well said. Yeah. Anyone in the open source world, we're all just standing on the shoulders of giants. And
yes.
you know, I always like to be like, I'm not actually this tall. I'm standing on this tall person's shoulders. Can
you are
you
not
see
tall.
that?
You're like this.
Well, you're very tall. Anyway, gosh, I had just a wonderful time. Renan, thank you for coming on. Everybody else, thank you for tuning in. I hope you found this as helpful as even just I did. I mean, I entered this totally ignorant of whatever code was behind this app, and was learning along with everyone. Renan, thanks for joining. Everybody, thanks for tuning in, and I will see you all next week.